Hello, I am Andrew Edwards, your virtual faculty at UniAthena. In this lesson, we will learn about NumPy libraries. NumPy stands for Numerical Python. It is one of the most useful libraries in Python, with many built-in functions. It is much faster than using a list or loops. While studying machine learning, NumPy comes in handy. When working with data, you often need to store values in rows and columns. NumPy contains multidimensional array and matrix data structures, which provides a homogeneous and dimensional array object, with methods to efficiently operate on it. NumPy provides high-performance multidimensional array objects and tools for manipulating those arrays. It is a general-purpose, array processing Python library package, which is used in almost every field of science and engineering. Moving on, let's discuss about these NumPy arrays. NumPy array is a powerful n-dimensional array object. ND-array is the n-dimensional array object, which stores the collection of the similar type of elements. The ND-array object can be created by using the array function. If we pass a list, tuple, or any array-like object into this array method, it will be converted into an ND array. A dimension in array is one level of nested array. Nested arrays are arrays that have arrays as their elements. We can create n-dimensional matrix like 0D, 1D, 2D, 3D, and so on, using NumPy. Let's understand this n-dimensional array with this table. If we look at the table, we can see that 0D array has one single element in an array. 1D array has n numbers of 0D arrays in it, and 2D array has n numbers of 1D arrays in it. Similarly, we can say that ND array has n number of n-1 dimensional arrays in it. Now let's write a program to do the same. Let's create n-dimensional array with NumPy arrays. First, we need to import NumPy package to our program. Let's write import NumPy as np. Here np is an alias we use for NumPy. Okay, so let's start with creating 0D array. Let's take a variable, say a0D equals np.array, and the value be 12. That's done. We have our 0D and D array. For 1D array, let's write three 0D arrays, say 1, 2, 3. Now let's place these 1D arrays inside one more array, separated by comma, to get 2D array. Similarly, if we place these 2D arrays inside one more array, separated by comma, we will get 3D array. Let's print these and see their array type. NDIM is a function that returns the number of dimensions of an array. Here we can see the results, saying what type of array we have created. Moving forward, let's look at the other basic NumPy operations, like index, slice, join, sort, split, and iterate, and understand these with an example program. Before performing any operations, we will be needing a data type. So, let us declare two ND arrays and assign some values to the same. Now let's start with indexing. It is the same as accessing an array element. You can do it by simply referring to the index number of the element. Here, say we need to access the first element of array. So type array name and index number between square bracket. Now let's slice this array to take elements from one given index to another given index. You just have to write array name, start position, colon, the end position, between square bracket. Here we will get element from first index to end index, excluding end index. Moving on to join operation, we have concatenate function to join two or more arrays into one along the axis. To do this, write np.concatenate array names separated by comma in between two brackets. If you need to sort the array into ascending or descending order, you can use sort function. You just have to type np.sort array name in between bracket. By default, sorting will be in ascending order. Moving on, let's split the array into three parts and iterate over them. Let's take a variable, say SA, to store the splitted array and type SA equals to np.array underscore split open bracket array comma 3 close bracket. Now to iterate over this array, NumPy package contains an multidimensional iterator object called NumPy, NDITER. Each element of an array is visited using Python's standard iterator interface. Let's run this and see our result. Here you can see the indexing result. We have got the value of index 0. Next we have sliced result with value from index 0 to 1. Here we have result of newly joined array. Sort function have returned array in ascending order. And finally, here is the result of splitted array, and we got this result by iterating. Keep practicing to understand more about all these commands. Now let's try to understand the purpose of NumPy. The Python data type, list, is slow to process, so NumPy arrays are used. Its main aim is to provide an array object, which is 50 times faster than lists. NumPy arrays are stored in contiguous locations in memory. This allows processes to access and manipulate them very efficiently. With that, we have come to the end of this lesson. Keep learning and practicing. Thank you.